Okay, so where were we? We had just finished, or we just started unzipping the DNA with this helicase enzyme, and we had started adding new base pairs to what's called the leading strand. It's called the leading strand because this is the direction that polymerase knows how to work. So remember, polymerase can only work in one direction, and this one has sort of like the opposite direction, right? So we're going to run into some issues here, and we're going to figure out how to deal with them. So the first thing you should notice about this diagram is just get yourself oriented to where everything is. So I couldn't find any good diagrams that went the other direction, so notice that it's kind of flipped. So before, helicase was moving right to left. In this case, helicase is moving left to right. We've just switch things around, so just be cautious of that. So here is our helicase moving in this direction, left to right, and here is our DNA polymerase. So this is polymerase here, this is a helicase here. Our DNA polymerase is just happily adding base pairs along this leading strand because that's the direction that it knows how to go. But then up here in the other direction, what you need to have happen is you have this enzyme, our third enzyme involved here, called DNA primase. And what DNA primase does is it comes and it adds a few segments. It adds a few segments of RNA in order to let polymerase know, okay, here's where I need to start. So DNA primase is going to come, it's going to add a few segments of RNA, and then you're going to have your let me get this out of the way. DNA polymerase. Then your DNA polymerase can start adding base pairs. Because again, it can only work one way, and it doesn't know which way to go. Okay, let's talk about this process. DNA helicase breaks the hydrogen bonds between the base pairs. DNA polymerase, then on the leading strand, goes ahead and adds your base pairs, adds your complementary base pairs, and it can just happily move from one end to another. Okay, as that process is happening, as polymerase is adding it, the DNA is starting to wind back up, and you can see that happening here on the leading strand. But we also have this lagging strand. And because polymerase can only work in one direction and doesn't know where to start, you need to have DNA primase come and add RNA segments to this so that your DNA polymerase knows kind of where it needs to go. After that, you wind up with these things called Okazaki fragments. Just to give you a slightly cleaner image of what an Okazaki fragment looks like, and again, I apologize, I have flipped it on you again, so now we're replicating that way, but in terms of the DNA, we haven't changed direction at all. But here's what your Okazaki fragments look like. So again, your RNA polymerase is going to just work its way down here. Okay, but your Okazaki fragments are because the RNA polymerase has to work sort of discontinuously. You wind up with those fragments where you have a segment of DNA and then you have another segment of DNA, but they aren't really connected to one another. And so ligase is going to come in and it's going to basically fix that connection. It's going to make it so that now instead of having these fragments of DNA that aren't connected correctly, now they are. Okay, it is fixing that bond. Okay, so I just rewatched all that and I realized I wasn't super clear when I was talking about the role of ligase. So like ligase fixes a bond between DNA. And it's not this bond, it's not the hydrogen bond, it's this bond. So when you add base pairs discontinuously, like we're forced to do because that's how polymerase has to work, this bond is not there between those different fragments of DNA. And what ligase is doing is it's coming in and it's reestablishing the bond between your deoxyribose sugar and your phosphate group. So let's do a quick review. We are replicating our DNA in S phase of interphase using the enzymes helicase, polymerase, primase, and ligase. Helicase opens up the DNA strand. Then polymerase comes and actually is adding new base pairs. Remember, polymerase doesn't know where to start and can only work in one direction. As a result of that, this fragment, this lagging strand where the polymerase has to work and sort of catch up every single time, you need primase to add RNA primers so that DNA polymerase knows where to go. The result of that is what is referred to as Okazaki fragments, okay, where you're having different pieces of DNA, but you're missing that bond between that deoxyribose sugar and the phosphate group. DNA ligase comes in and solves that. So, things for you to know. The 4 enzymes that we had discussed, DNA has directionality. It is important because polymerase can only work in one direction. You should know what an Okazaki fragment is. And how do we contend with that? And the answer to that is we use ligase to fix that broken, it's not broken, but to fix that segment of DNA.